All right, let's look at the homework 8, problem number 4. All right, so we have this function, f of x equals natural log of x squared plus 9, right? We want to find the domain, right? So natural log cannot take a negative value or 0, but you can see that the x squared plus 9 is at least 9, so we can plug in any x you want. So its domain is all real numbers, right? So we got that. All right, so that was easy. All right, next one, we want to find the X-Intercepts. All right, so let's do that. All right, so in order to find X-Intercept, we're gonna set this guy equal to 0. All right, so we're gonna X-intercept. Then we're gonna set y equal to 0, y being that function. So we're going to have this equation. So you have a natural log of x squared plus 9, right? And set that equal to 0, right? Then try to solve and see what happens. So if you raise e to both sides. So you have e to the natural log of x squared plus 9 is equal to e to the 0. And you can see that exponential function and log functions are inverses of each other. And also this guy, e to the 0, is 1. So what you get is this equation, x squared plus 9 is equal to 1. And you can see that this one doesn't have any, has no real solution, because if you subtract 9, we know that the x squared has to be equal to negative 8, right? So there's no such value, so there's no x-intercept. So we're gonna say, so we're gonna go up here, and there are no x-intercepts, right? So check that, all right? We got that. All right, and the next is we want to find the y-intercept. All right, so we're gonna put y-intercept. So to find the y-intercept, and we're gonna set x equals 0, right? So it's going to be y is equal to, right? X is 0, so you have a natural log of 0 squared plus 9, which is equal to natural log of 9. All right, let's say natural log 9, but we have to round it to 1 decimal place. So let's do that. I'm going to just bring up GeoGebra. All right, so natural log of 9 and hit enter. So it's y is about 2.2. All right, so let's check the answer. All right, we got that. All right, and then we want to see if there's a vertical asymptote, but in this case, this function is defined everywhere, and there's no vertical asymptote. All right, so we got that. All right, and here, horizontal asymptote. If you look at it, if you take the limit as x approaches infinity, so it's going to go to infinity anyway, so we're not going to have any horizontal asymptotes either, because we have to get a finite value, so it's going to be no horizontal asymptotes. All right, so we got that. And then let's see, summarize, oh, increasing, decreasing behavior. So let's look at the derivative. All right, so you have f prime of x is equal to, all right, so remember that when you have a natural log of something, you just have to put that, whatever the expression inside the natural log, put it on the bottom, take the derivative of that, put it on top, so it's a 2x. All right. So I'm going to set that equal to 0 to find the critical value. So you can see that we need to make the numerator equal to 0, and which means that we can divide through by 2 to get x equals 0. So 0 is a critical number, right? Then we're going to do a number line. So draw a number line there. All right, sorry, I can't draw a straight line. All right, so x is 0, and so we look at the sign of f prime. All right, I'm going to try something less than 0, which is -1. All right, if you plug in -1 in here, so you have a negative on top, and the denominator is always positive, so you have a negative first derivative. If x is positive, so positive 1, you can see that you have a positive and a positive, so you're going to have a positive. So we know that the original function is in the beginning decreasing before 0. After 0, it's increasing. All right, let's pick the answer. All right, so it's going to be increasing on the interval starting from 0, right? So you're going to starting from 0 to infinity. All right, and then decreasing in the beginning from -infinity to 0. All right, so we have that. Let's see, we need to let's answer interval notation, so it should be fine. Let's check the answer. Oh, actually, okay, so technically this should be correct, but I think they're looking for an open interval. So let's try that. All right, we got that. All right, so make sure to put an open interval there. All right, so then it has a local. All right, so it's going to let's look at that. All right, so it's a decreasing turning into increasing, so it's going to be a local minimum, right? So at this point, you're going to have a local minimum because you have a valley there. All right, so I'm going to go back out here. You're going to have a local minimum, right? Check that. Got that. All right, then we're going to look at the concavity. All right, so we're going to have to take another derivative. All right, so we have f double prime of x is equal to denominator squared. So square the denominator. So I'm just doing the quotient rule. And actually, I'm going to put 2 outside because it's not going to really do anything there. So you have a derivative of x is 1. And times the denominator would be x squared plus 9 minus top would be x and times derivative of the bottom, which is 2x, right? So this is going to be equal to, all right, so 2 is in front, and then you have x squared minus 2x squared, so it's going to be 9 minus x squared over quantity x squared plus 9 squared, right? So I'm going to set that equal to 0, and you can see that here, numerator equal to 0, so 2, and 9 minus x squared would be 3 plus x times quantity 3 minus x, and we set that equal to 0. Which means that we have x is going to be plus or minus 3, right? Then we're going to do a number line again here. All right, so we're going to put a tick marks at -3 and a +3. And look at the sign of the second derivative. All right, let's try anything smaller than -3. I'm trying -4. All right, if you plug in -4 here, all right, you can see that the 9 minus 16, so that's going to be negative. So you have a negative sign there, all right? And anything between -3 and a +3 are like 0. All right, if you plug in 0, the second derivative is going to be positive, all right? And if you try x equals 4, you can see 9 minus 16, so that's going to be negative. Denominator is positive, so it's going to be negative, which means that the original function is going to start out concave downward, and then you have a concave upward between -3 and 3, and a concave downward. All right, so let's put the answer there. All right, it's a concave upward between -3 and +3. Oops, I didn't write that. All right, so here. And the concave downward on -∞ to -3. And we're going to separate with comma, so we have a +3 to +∞. All right, let's check the answer. We got that. All right, and we want to find the inflection point. And if you look at it, you can see that the concavity change happens at x equals -3. So there's going to be an inflection point there. And also here you have an inflection point. All right, so we're going to put that here. So inflection points are x equals -3 and also +3. All right, check the answer. We got that. All right, and then look at the picture. All right, remember that it's going to be, let's see, we're going to have decreasing and increasing, concave down, concave up, concave down. All right, who has that shape? Right, so this is not the correct one, right? Because it's going to be decreasing, increasing. So this is okay. This one's okay. This one is eliminated, decreasing, increasing, decreasing, increasing. So it's going to be between these two guys. And a concavity is concave down. Well, it looks like a concave up all the way through. This one, concave down, concave up in between, and then concave down again. So C is the correct picture. All right, let's check the answer. We got that. All right, that's it. I hope that this was clear.